Okay, this is the 7th grade dynamics practice quiz. Problem number 1. 140 Newton car accelerated at a rate of 7 meters per second squared. How much force was acting on the car? This is a relatively straightforward problem. Note that this is 140 newtons, not kilograms. So we're just going to divide that by the acceleration due to gravity, which is approximately 10. So this is going to be 140 divided by 10 is equal to 14. Then we have our force is equal to our mass times acceleration equation, which is going to be 14 times 7, which is going to equal 98. And that is the answer. Okay, we have a block of wood that has an unknown mass. It accelerates at 3 meters per second squared when 30 newtons of force are placed on it. What is the mass of the block of wood? All right, so we still have our force is equal to ma equation. Our acceleration is going to be 3, our force is going to be 30, and we want to know what the mass is. Divide both sides by 3. Mass is going to equal 10. A 600 kilogram plane is sitting on the runway. Its engines place 2,400 newtons of force in the plane. The plane accelerates at a rate of 2 meters per second squared. What is the force of friction on the plane? All right, so we have a combination of forces here. We're going to have a 2,400 newtons of this way, and then we're going to have some force of friction. There's a couple of different ways to solve this. The pathway I like is this combination of forces set up. So I have 2,400 newtons of force this way, and I'm going to add to that, if this is positive, then this has to be negative, some force of friction. And that's going to equal my mass, 600 times my acceleration due to gravity, which in this case is not due to gravity, just the acceleration, which is 2. So that's 2,400 minus force of friction equals 2 times 600 is 1,200. All right, rearranging this equation, we're going to subtract 100. And we're going to add force of friction to both sides, and that's going to give us 1,200 equals my force of friction, which is here. A 5 Newton book is sitting on the desk. What is the mass of the book? The acceleration due to gravity is 10 meters per second squared. This is a relatively simple one in terms of the number of steps. This is going to be 5 equals m times g, divide both sides by 10. The mass is going to equal 1/2 or 0.5. A plane is sitting on the runway. The runway is 900 meters long. Sorry about the focus there. A little better. The runway is 900 meters long. The engines can place 1,600 newtons of force on the plane. The plane must achieve a velocity of 60 meters per second by the time it reaches the end of the runway in order to take off and not crash and burn. The plane is empty and has this empty mass of 250 kilograms. What is the maximum mass, passengers and cargo, that can be loaded onto the plane before it's too heavy and crashes? So in the world of Boeing, hopefully this problem has some relevance. So we have this runway. It is 900 meters long. So our distance or displacement is 900. Our force is 1,600. And our final velocity is 60. And then we have some sort of mass 1, which is equal to 250, and mass 2 we are not sure about. So I'm seeing some forces, I'm seeing some displacement and final velocity. That means I need some combination of force and kinematics. What can I do with that? Well, I have an initial velocity of 0, right? It's sitting on the freeway, or the runway. So let's go ahead and put this into our distance equation with final velocity squared equals my initial velocity squared plus 2 times the acceleration times our displacement, and I am looking for acceleration. So my final velocity is going to be 60 squared minus 0 squared is equal to 2 times the acceleration times the displacement, which is 900. So this is going to be 60 squared, which I don't know off that well. It's going to be 36 100. And we are 2 times 900 is going to be 1800. Divide both sides by 1800, and we are going to get the acceleration is 2 meters per second squared. So now I need my force equation. Force is going to equal mass times acceleration. My force, which we know that's given in our problem, is 1600 equals mass times 2. Divide both sides by 2. That gives us a mass of 800. Now this is the total mass, right? This includes the empty weight of the plane and all of the cargo. We just want the passengers and cargo. So we're going to take 800 and we're going to subtract out the 250, and that is going to give us 550 kilograms, and that is the answer. Right. Number 6. A 400 kilogram car is traveling along the road. Its engines place 1600 newtons of force on the car. The car accelerates for 8 seconds and a displacement of 200 meters. What is the initial velocity of the car? So we have a mass of 400, a force of 1600, an acceleration, I don't know, and a time of 8 seconds, and a displacement of 200 meters. That makes me think that I need to use one of my kinematics equations to solve. So to start with, because I don't know my initial velocity, I'm going to start with my force is equal to my mass times the acceleration equation, because I've got that. After that, I'm going to use my my distance is going to equal my initial velocity, or times 0 if you like, plus 1/2 a t squared. All right, so let's go ahead and start with this one. My force is going to be 1600 equals 400 for my mass, and my acceleration we don't know. Divide both sides by 400. My acceleration equals 4. So let's go ahead and plug that into here. So my distance is going to be 200, or my displacement I should say, equals my initial velocity, which I don't know, times 8 plus 1/2 times 4 times 8 squared. So that's going to be 200 equals 8v plus 1/2 times 4 is 2 times 8 is 64 plus 128. Right, we're going to subtract 128 on this side. And that is going to give me 72. I divide both sides by 8, 9. So the initial velocity is 9 meters per second. It's 600 meters to Billy's school from his house. If Billy starts at 7:30 and gets to school at 7:45 and realizes it's Sunday and there's no school, immediately turns around and goes home. He gets home at 8:15. What is Billy's average speed? So these are kind of a continuation of speed versus velocity problems. So for a velocity problem, if he starts at home and he goes to school, and this is 600 meters, and then he goes from school to home. This is also 600 meters. So the velocity is going to be 0, the average velocity, because the displacement is 0. He's starting back where he ended back where he started. But this is asking for speed, so we don't actually need to do that whole process. The average speed is going to be the total distance divided by the total amount of time, which in this case is going to be 15 and 30. It's going to be 45. Now, you have to be careful here because this is 45 minutes, and none of these are in minutes. These are in seconds. So you're going to multiply that by 60 in order to convert. So I'm going to have 1200 divided by 45 divided by 60 is 0.44. Jimothy has a mass of 50 kilograms. He places 500 newtons of force on the Earth. The Earth has a mass of 6 times 10 to the 24th kilograms. What is the acceleration of the Earth? Okay, this is a somewhat humorous Newton's third law problem. So for every action, there's an equal and opposite reaction. The action here is 500 newtons of force. So 500 newtons equals the mass of the Earth, 6 times 10 to the 24th. My acceleration. So I divide both sides by 6 times 10 to the 24th. I bring up my scientific calculator. 6e to the 24th equals 8.3 times 10 to the negative 23. So this is far, far less than what would potentially be measurable. So this type of acceleration wouldn't even cancel out the vibrational energy of the atom. So for all effective purposes, the movement would be 0, but we can get a mathematical result, and that's what this problem is asking. A 500 kilogram cart is being pushed by an engine supplying 2,500 newtons of force. If the cart starts at 2 meters per second and ends at 12 meters per second, how much time does it take for the cart to accelerate? So we need to figure out the acceleration. And our formula for acceleration is final velocity minus the initial velocity over time. So I'm going to go ahead and rearrange that as time is equal to our final velocity minus initial velocity divided by acceleration. We still need the acceleration, so let's go ahead and plug that in from our force equation. So that's going to be 2500 equals 500. Acceleration, divide both sides by 500. Acceleration is equal to 5. So this is going to be 12 minus 2 over 5, which is going to equal 10 over 5, which is equal to 2. So this will take 2 seconds. A box is being pulled along the ground. It experiences 5 newtons of friction. If it takes 4 seconds to accelerate the box from 2 to 18, how much force is being applied to the box? This is just force is equal to mass times acceleration problem. And to figure out our acceleration, we're going to go back and we're going to do our acceleration equation from kinematics, and that's going to be 18 minus 2 over 4, which is 16 over 4, which is equal to 4. And that's our acceleration. So our mass is going to be 6 times 4, and that's going to equal 24. Okay, so that is our mass. So now, or I'm sorry, our force. Now this is our net force. This is the total amount of force that can be on this box once we take into account friction. So we need to add friction to this. So our applied force is going to equal 29. If you want to do this sort of another strategy, then we can do it this way. We can do our force 1 plus force 2 equals mass times acceleration, in which case we have an applied force, which we don't know, plus a negative 5 is going to equal our acceleration of 4 times 6. So that is going to be F minus 5 equals 24. F is equal to 29. Right, I'm just adding both 5 to both sides. Right, so there's 2 ways to solve that particular problem. Personally, I prefer this way. It's a little bit more mathematically rigorous, and it helps keep the forces kind of separate and sort of obvious. If you make a mistake on this problem, it's much easier to see what's happening here and can go back and fix it. With this one, sometimes it's easy to get our positives and negatives mixed up, or it's easy to kind of forget and see that, well, this is our net force, but it's asking for applied force. And so we might be tempted to think that this is the answer to the problem when this is the answer to the problem, right? So for that reason, I prefer using this strategy to solve problems. A box is pulled in two directions. It experiences 6 newtons of friction in one direction, and in the other direction it's being pulled in 40 newtons of force, and this would be 30 over here. If the box accelerates from 3 to 9 in 3 seconds, what is the mass of the box? So we don't know that part. So our net force over here is 36. Or, well, I shouldn't say net force. Our force in this direction is 36, 40 over here. So our net force is going to equal 40 minus 36, which is equal to 4. Okay. So our acceleration now is 3 minus 9, so 9 minus 3 over 3, which is 6 over 3, is equal to 2. So 4 is equal to 2, which is our acceleration, times our mass. Our answer is 2 kilograms. 12. A car traveling 5 meters per second has a mass of 500 kilograms. It experiences a force of 1,000 newtons for 5 seconds. At the end of that 5 seconds, the engine shuts off and the car has no more forces in the horizontal direction for 5 seconds. We're ignoring friction here. How far did the car go after this engine is shut off? So this is a kind of a question where there's two sort of separate pieces of this. Right? We have this sort of initial scenario where the car has some sort of initial speed and then has a speed after that, so some sort of velocity here. And it has some sort of acceleration. Acceleration is greater than 0. On this side, the acceleration is equal to 0. Okay? And there's no friction here, so it's not slowing down. That's what equals to 0 means. And so we need to figure out the distance here. So the velocity at this point and the velocity at this point are the same. And so we have a time component, which is 10 seconds. Our time component over here is 5 seconds. And we are looking for a distance. We actually don't care what this distance is, although we could calculate it certainly if we really wanted to, but we don't. Let's go ahead and figure out what our acceleration is going to be. We have a force of 1,000. It's going to equal 500 times our acceleration. So divide both sides by 500. Acceleration is equal to 2. Okay? So acceleration is equal to 2 over on this side of the equation. If it's doing this for 5 seconds, so that's going to be 2 times 5, that's going to equal a change in velocity of 10. So if our change in velocity is 10 and we're starting with 5, so our v here is going to equal 15. We can put that formally into our kinematics acceleration equation if we really want to. So our initial velocity is 5 minus our final velocity over a time, which is 5, equals 2. So 5 times 2 is 10, so v minus 5 equals 10. V plus 5 to both sides is equal 15. So we can just do it formally in terms of math if we want, but we can also just sort of highlight this process. Okay, so we know that this is 15, and we know that this is 15, although that's not really important to us. Can we calculate this distance with time? Sure we can. So that's our distance is going to equal velocity times time. If our velocity is 15 and our time is 10, our distance is going to equal 150. There you go. An 800 kilogram car is traveling at 40 meters per second. The driver takes his foot off the gas pedal and the car begins to accelerate. If it experiences a force of friction of 320 newtons, how long will it take for the car to stop? I had a number of questions about this word accelerate. Remember, accelerate equals a change in velocity. This is the definition, right? So this change can be negative. If it's negative, that means it's slowing down. We don't like to say slowing down and accelerate in casual language. That is the purpose of this question, is to highlight the fact that when we say accelerate, we can get a negative acceleration. We can mean slowing down. We can also say changing direction as well. So let's go back to this problem. 800 kilograms, we are looking at a force. So the force is going in the opposite direction of the way the car is going. So let's figure out what the acceleration is. So this is going to be 3,200 equals 800 times our acceleration, divided both sides by 800. Acceleration is equal to 4. Okay, let's figure out how long it takes for the car to stop. So if the initial velocity is 40 meters per second, and we are going to subtract that from some sort of final velocity, and this is going to be over time, and this is going to equal a negative 4. Why a negative 4? Strictly speaking, this force of friction is going in the opposite direction as the car, so this really should be negative, right? So we can check ourselves by saying if the car is slowing down, we're going to have a negative velocity, so we should have that there. So we're going to rearrange this equation, cross multiplication, all that. So that is going to be negative 40 divided by negative 4 is going to equal 10. And that is what we get right here. And this is going to be in seconds. There's a 40 kilogram ball rolling around towards a 10 kilogram ball. The 40 kilogram ball strikes the 10 kilogram ball. It applies a force of 60 newtons into the 10 kilogram ball. The 10 kilogram ball accelerates in the opposite direction of 16 meters per second squared. How much does the 40 kilogram ball accelerate? So this is an action-reaction pair. This is probably not the ideal way to go about this, but we'll get to momentum in sort of a later lesson. So our initial forces, let's figure that out. We have a 10 kilogram ball accelerating in this direction at 16 meters per second. So we have 10, and it's going this way, 16 meters per second. This is going to make our force to do this 160 newtons. So what is this one going to equal? So this is going to be the same 160 newtons equals our mass times our acceleration. So our acceleration, and this is going to be an absolute value at this exact moment, is going to be 4. All right, so it's going to be positive or is it going to be negative? That's the question. So if the 10 kilogram ball is moving in a positive direction, then so this is then going to be a negative. I don't really like how this question is worded. It's kind of a confusingly worded question, but this would be our acceleration in the opposite direction. The cannon question. A 1,000 kilogram cannon is placed on a fort and fires a 5 kilogram ball towards the enemy. When the cannonball leaves the cannon, it's traveling at 100 meters per second and takes 0.1 seconds for the ball to leave the cannon. The cannon experiences an acceleration for 0.1 seconds. Assuming no force or friction, what is the velocity of the cannon once the ball leaves the cannon? So keep in mind that we're talking about the cannon here, and this is once the ball leaves. So we have two different things. This is an application of Newton's third law. So you'll see this a lot with recoil type questions for any sort of ballistic motion, for any sort of rocket or cannon or anything like that. So so if any of you have experienced any kind of recoil, then you kind of know kind of intuitively what we're talking about here. So let's go ahead and figure out what the force on this ball is. We'll go ahead and draw kind of a diagram it out. Okay, and we have a little ball and it's going in this direction, not to scale apparently. This is 5 kilograms, and there's a force from this cannon on this ball, and Newton's third law says there is a force on this ball, on this cannon. So let's figure out what this is. So our acceleration equation, final velocity minus initial velocity over time, applies here, and we have an initial velocity of 0 when the cannonball was here. It had no initial velocity. So the final velocity is 100 over 0.1, which is going to equal 1,000. Okay. Our force is going to equal 1,000 times our mass, which is 5. It's going to equal 5,000 newtons. So our cannon can put 5,000 newtons of force on this cannonball. That means the cannonball is putting 5,000 newtons of force on the cannon. So let's go ahead and figure out the acceleration on the cannon. So this is going to be 5,000 equals 1,000 times our acceleration. Our acceleration is going to be 5 meters per second squared. If it does this for 0.1 seconds, then we can have a final velocity for this. So again, our initial velocity is going to be 0, so our final velocity minus 0 over 0.1 equal 1 is going to equal 5. So 5 times 0.1, our final velocity is going to equal 0.5 meters per second. If you double the force on an object but keep the mass the same, what happens to the acceleration? The acceleration doubles. That was simple in terms of the number of steps that it took. All right, a 2 kilogram ball is sitting on the ground. A 50 kilogram athlete comes and kicks the ball with a force of 100 newtons. What do we know to be true? Okay, so if you've ever seen people kicking a ball, then you know that the ball is going to move. So we know that these two things aren't right. Is the ball going to be balanced or unbalanced? Well, we're tempted to say balanced because we think that for every action there's an opposite and equal reaction, and that is true. But those happen on different things. The opposite and equal happen on the ball and the kick. Can I draw? Well, I can sort of draw a foot. Right? So the force this way and the force on this are the same. However, just thinking about this force, there's nothing keeping this ball here. There's no backwards force on the ball. There's a backwards force on the foot. If you've ever kicked a ball with your bare toes, you know that there's a force on your foot. It can kind of hurt, depending on how hard you kick it, right? So just on this, though, just on the ball, there is no opposite equal force on the ball. Again, there is one on the foot. So they're happening on two different objects. So on the ball, this is an unbalanced force. There's only one force pushing it this direction. If there's friction or something, then that might apply, but it would be far less than the force on the foot. So the forces are unbalanced. If the forces are unbalanced, then you're going to get some kind of acceleration. That's kind of a tricky nuance for a lot of students. A 750 kilogram object at rest has 15 newtons pulling to the left and 55 newtons of force pulling to the right for 100 meters. How much time did that take? So we have 750 kilograms here, It's pulling to the left. It's 15 to the left and 55 to the right, and 400 meters. What is our net force? Force net is going to equal 55 minus 15, and that's going to equal our mass, which is 750 times our acceleration. Divide both sides by 750. Let's get our calculator out here. So this is going to be 40 divided by 750. So 0.33, that is our acceleration. I'm just going to leave that there. Okay. How much time did it take to go 100 meters? So we're looking for a distance involving time. That's distance equals 1/2 our acceleration times our time squared. So there's also an initial velocity, but our initial velocity is 0, so I'm not going to include that term. So that's going to be 100 equals 1/2 times 0.0533 times time squared. So we have 100 divided by, so 200 divided by 0.0533, and that is going to equal, so 2 times, and then divide by 0.0533, and that is going to equal 3752, but we're not done yet, right? Because that equals t squared. So to find our time, we need to take the absolute, or not the absolute value, we need to take the square root of that. So time is equal to 61.25. Or looks like we're rounding a little bit. Okay, and that is how we do that. The minimum amount of force required to move a 600 kilogram object if the coefficient of friction is 0.4. 600, our force of gravity is going to equal 6,000. Our force normal is also going to equal 6,000 in the opposite direction. And our force of friction is going to equal our coefficient of friction times force normal, so that it's going to be 0.4 times 6,000. 0.4 times 6,000 equals 2,400. So you have to have more than that in order to calculate, or in order to accelerate that object. Okay, we have this box. It is 4.2 kilograms. It is being moved with this, and determine the coefficient of kinetic friction. So we have, again, this force of friction equals the coefficient of friction times force normal. Force of gravity is equal to 42. Force normal is 42 in the opposite direction. So this is going to be 55, because remember, it has to be the same. If we are talking about constant velocity, that means there's no acceleration, meaning our forces are balanced, meaning the 55 has to be the same on both sides. So 55 equals the coefficient of friction divided by, or times 42, divide both sides by 42. I believe that's 1.3. It is. So plus a bit. Right, and that is how you do that.